The dissolution process involves two stages. The first one, which is the breaking down of the ionic lattice, and the process is endothermic, and the process is called lattice dissociation. This is followed by subsequent stabilization of the ions in aqueous state through the formation of ion-dipole interactions, and the process is called hydration, the enthalpy change being enthalpy change of hydration. It is always exothermic because it involves bond formation. Like in this case, the chloride ion is interacting with hydrogen with a partial positive charge, and the sodium ion is interacting with oxygen atom with a partial negative charge. The rule at work is unlike charges attracts and like charges repel. Compounds dissolve in water to form aqueous solutions. The amount of dissolved solute differ from substance to substance, and this is also affected by temperature. A saturated solution is formed when a homogeneous mixture of dissolved solute came into dynamic equilibrium with undissolved solute. Take place at molecular level when the solution is saturated. So we are dissolving sodium chloride. Sodium chloride is very soluble. Okay, now the solution is saturated. And in a saturated solution, an equilibrium exists between the sodium chloride in solid state and sodium ions as well as the chloride ions. So, for example, in this case, the amount of dissolved sodium ions and chloride ions is almost constant. So, but both dissociation and association still occur at the same rate. So we are now in a dynamic equilibrium. Solubility of these ionic compounds varies. For example, using a sparingly soluble ionic salt such as strontium phosphate, only fewer strontium phosphate manage to dissolve in water. Constant Ksp, it refers to the product of the concentrations of the ions in a saturated solution raised to its respective power in accordance to the solubility equation. For example, in this case we have strontium phosphate. The Ksp expression becomes constant. Ksp is only affected by temperature. Under the definition ionic product, it refers to the product of the instantaneous concentrations of the ions in the solutions raised to its respective power in accordance to the solubility equation. It has the same expression as Ksp. Ionic product can be calculated at any point during dissolution, and it is used to predict precipitation. For example, if ionic product is greater than Ksp, it means precipitation would occur until ionic product is equal to Ksp when the solution becomes saturated. Then if ionic product is less than Ksp, precipitation would not Okay. KSP value is fixed at a particular temperature, and according to Le principle, excess ions will shift equilibrium position to the right, forming a precipitate while reducing the concentration of the ions. If ionic product is greater than KSP, this can be applied in qualitative analysis test for sulfate as an example using barium nitrate or barium chloride.